Today we are going to discuss a system of first order ODEs. System of first order ODEs. Okay. We had discussed what is a first order ODE and how to solve it. We studied different methods for solving first order ODEs, for example, separable ODE, linear ODE, exact ODEs, and some other techniques. Now we know that a first order ODE can be written as dy by dx is equal to some function of x and y, where y is the dependent variable. Y is basically the dependent variable. You can write in some other variables, for example, you can write dx by dt, dx by dt is equal to some function f of here, the independent variable t and x, which is the dependent variable. So x here is the dependent variable and the t is the independent variable. In physics, we usually use this notation, and in mathematics, we usually use this notation. So this was basically the first order ODE. And we know that how to solve it. It includes different techniques which can solve linear first order ODE, nonlinear first order ODEs. Now today we are going to discuss what is a system of first order ODEs and how to handle it, how to solve it. In general, how can we write a system of first order ODEs? In that, we need to define if n dependent variables. If the system is generally, it contains n dependent variables. So there is one independent variable t. Okay, this is basically independent variable. And we need to define n dependent variables. For example, we can define y1, y2, so on, yn, or x1 of t, x2 of t, and so on, xn of t. These are all dependent variables. And all these dependent variables, or they are functions of t only, there must be domain. So we assume that t is defined on some interval a to b, or you can say that t belongs to some interval I, which is ab, this interval. Then we can define a system of first order ODE in this form as dx1 by dt is equal to some function f1 of t, which is the independent variable, and now all the dependent variables, x1, x2, so on, xn. Second, dx2 by dt is equal to some other function f2, which is a function of independent variable plus all the dependent variables, xn, and so on. In general, we can define dxn by dt is equal to some function fn of tx1, x2, so on, xn. So this is how we can define a system of first order ODE. We call this system system 1. Is there any question, Gigi?
सर इसके अंदर जो f1, f2, fn ये सारे हैं, ये सारे फर्स्ट डेरिवेटिव्स हैं dx1 by dt और dx2 by dt, या फिर dx2 by dt सेकंड डेरिवेटिव है?
No, the x1, x2, xn, they are n independent variables. They are not derivatives. Okay, they are different variables. For example, if I define system of two differential equations, then I can use different variables. There, I have to define n variables, so I took the index of all the variables. For example, I can define dy by dt is equal to some f of txy, okay? And the other variable, independent variable, is dx, x, which is a function of t. In that case, we can define some function gxy. So this is basically a system of two first order ODEs, okay, where x and y are both dependent variables. X is a function of t and y is also a function of t. T is only a independent variable which belongs to some interval I, which could be AB, where AB belongs to R. Okay, Y is dependent, X is dependent, and they depend on T because the derivative is with respect to T. So it could be a function T, function f of T, independent variable, and the dependent variable. For example, let we write example of this thing. Dy by dt is some function, you can say t square x plus 2y plus maybe 3, and dx by dt is equal to x square plus maybe xy plus sine t. Okay, so this is an example of first order system of first order ODEs, and this system contains two first order ODEs: dy by dt, tx square plus 2y plus 3, and then dx by dt is equal to x square plus xy plus sine t. Okay. Where what is this? This is your first function, and we can write this thing as dy by dt is equal to some function of what? What is this function of? It is a function of t, x, and y. So we can write this as some function f t of f of txy. Similarly, the other equation can be written as dx by dt is equal to some other function. We can call it f1 and we can call it f2. So it is again a function of x, y, and t. So we can write it is a function of x, y, and t. Where f1 is what? F1 is this function. And f2 is what? F2 is this function. Now you can see that f1, this function, it could be a linear function as well as non-linear function of x, y, and t. There are people which need to. So f1 here in this case, it is linear in x and y. It is linear in x and y because x and y are dependent variables. So we need to see that whether this function is linear in x and y or not. It is linear because here we have x power 1, y power 1. But this function is non-linear in x and y as well. Because x here it has power 2. And here we have product of two dependent variables. Here we have 1, 1. So in total we have power 2 here. So this function is non-linear. So what do we get from here? That these functions could be linear functions of xy or non-linear functions of xy. If these functions are linear functions of xy, then the system of linear equation is called a linear system of first order ODEs. If they are non-linear, then we call them non-linear system of first order ODEs. I hope you get it. Let's see another example. For example, we write here a system dx1 by dt is equal to 2x plus 3y plus 5t, and dx2 by dt is equal to 9x minus 3, maybe minus 7y plus sine of t, and here you have 2. Now in this system, I assume that x1 is dependent variable and x2 is dependent variable, and they depend on t. where t is the domain of the independent variable. We assume that t is defined here. T belongs to maybe 0 to 1 or 0 to infinity or anything. So this is your system of first order ODEs. Now you can see that this function f1 of t x1 x2, and this is a function of f2 t of x1 and x2. But you notice here that the variables, dependent variables. So sorry. I have to write here x1 and x2. So this is x1, this is 3x2 and 7x2. Here we have 9x1. So now you can see that x1 and x2 are linear. They have only power 1. Here we have power 1, power 1. So the right hand side means f1 and f2, they are linear functions of x1 and x2. Okay. They are linear functions of x1 and x2. So this system of first order ODEs is linear system. Is linear. If a system of first order ODE is linear, then we can write it in a matrix form. In a matrix form. How can we write it in a matrix form? We put this thing in a vector, dx1 by dt and dx2 by dt. This is a 2 by 1 vector is equal to. Now you can see that we can separate the coefficient of x1 and x2 into a matrix, and we can write 2, 3, 9, and minus 7 times x1 and x2 plus the functions of t which do not involve x1 and x2. So we can write another vector here, 5t and 2 sine t. This. So every linear system which is linear in x and y can be written into the matrix form. And furthermore, we can write this thing. No, we don't have here. Let's go to the other board. Two. This one. Now that system can further be written as d by dt of x1, x2 is equal to the same 2, 3, 9 minus 7 times x1, x2 plus 5t and 2 sine t. This thing. If I assume that this is your matrix A and this is a vector X, okay, and this is some vector of which is a function of t, then let me admit the people. This is some function f, some vector f of t only. And this is again your x vector because it is again here. So we can write dx vector by dt is equal to a times x vector plus some f vector. So in short, we can write that linear system into this form. I hope you get it. If you have any question, you can ask me. Where A is this matrix, this x1, x2 is the x vector, and d by dt of x vector and this is your f vector, which contains, this is basically a function of t. Now this is basically is a matrix form, of linear first order system of ODEs. One other thing which we need to mention, I need to mention here is that when there is this function f of t and it is non-zero, then this system is called linear non-homogeneous first order linear system, first order system of ODEs. Okay, if this f of t is not equal to 0, this vector is not equal to 0, then we call that this system is non-homogeneous linear system of first order ODEs. If this vector is 0 here, for example, if we don't have this vector, okay, in that system of first order ODEs, then the system dx by dt is equal to a times x. We get this, and it is called is a homogeneous linear system of first order differential equations. I hope you get it. If you have any question, you can ask me. There's a question in the chat window. Let me see it. Sir, can we please have our quiz in the next class? Okay. I hope you get it. If you have any question, you can ask me. And in general, linear first order system can be written in this form. Can be written general linear system of first order ODEs. Linear system of first order ODEs. Before we have written a general system of first order ODEs. In that, the ODEs, the first order ODEs, they might not be linear. Now, if they are all linear, then how can we write it that dx1 by dt is equal to f1 of, sorry, not f1. Now, we will write the linear form of that f function. We say that it is a11 of t x1 plus a12 of t x2 plus so on plus a1n of t xn plus some g1 of t, which is only the function of t. And then dx2 by dt is equal to a12 of t x1 plus a21 and then a22 of t x2 plus so on plus a2n of t xn plus g2 of t. This will be a second now, and so on. Every term we will generalize it, and we can write dxn by dt is equal to an1 of t x1 plus an2 of t x2 plus so on plus ann of t xn plus some gn of t. This. So this is your system of first order, linear system of first order ODEs. All these functions are now, this is basically what this function, this whole thing is what it is, f1 of t, x1, x2, so on, xn. Now this function could be linear or non-linear. If it is linear, then we can write it in this form, where x1, x2, they are all linear, they have powers 1, and their coefficient functions, they are functions of t, a11 of t, a12 of t, they are the functions of t only. They cannot involve x1 or x2. Okay, they cannot involve dependent variables. They could be functions of t only, or they could be constants. Okay, as we have written the previous example, 2x1 plus 3x2. Okay. In that example, the coefficients were constants only. Okay, but they could be functions of t as well. Now this is your linear system of first order ODEs, plus it is non-homogeneous as well. It is non-homogeneous. Okay, now we can write this system if we call this as a G vector, and then we can write this whole system into a matrix form by writing d by dt of x1, x2, so on, xn is equal to a matrix which is a11 of t, a12 of t, plus so on, a1n of t. And here a21 of t, a22 of t, so on, a2n of t, and so on, and so on, and so on, an1 of t, an2 of t, plus so on, and the last one is ann of t times x1 of t, x2 of t, so on, xn of t, plus a vector which doesn't involve the dependent variables, which we call g1 of t, g2 of t. किसी का mic on है, kindly turn off your mic. So this is how we can write the system into a matrix form, and further by assuming that this is your x vector, this is your A matrix, and this is your G vector, we can write this thing as dx by dt. Now x is a vector, you have to put a bar here. It is equal to A times x plus some G vector, which is a function of t only. Now this is your general nth order, because it has n differential equations with n unknown variables. Then this is basically a system of n first order linear non-homogeneous ODEs. If this is 0, then we call it homogeneous linear system. I hope you get it. If you have any question, you can ask me. There's a question in the chat window, maybe. What is this? Can linear non-homogeneous system have A11 or A12 or A1n as something that is more than the function of t or constant? No, they could be only the function of t. Okay, who is this? Faik Bilal, you can talk to me, turn on your mic and ask your question if you have any concern. Kyun Faik?
Okay, sir. Thank you.
Talk to me. They are only the function of t. If they involve dependent variable x1 and x2, then this system will would become a non-linear system, and a non-linear system cannot be, we cannot write that linear system into matrix form. Why? Let's go back to the example 1, which we discussed on the first board here. Second, this one. Can you write this system into matrix form? Let's try. Okay, left hand side, so we can write it d by dt x y. Okay, equal to, we have to write the coefficient of x1 and x2 into matrix, and here we have to write x and y, ठीक है, plus some vector which doesn't involve, यहाँ पे आ जाएगा 3 sin t, ठीक है. Can we separate the coefficients here of x and y in first equation? Yes, x1 का coefficient क्या है, t square, y1, y का coefficient क्या है, 2. But here x square का कोफिशिएंट, यहाँ पे x तो नहीं है, तो x square है यहाँ पे. इसी तरह यहाँ पे x into y है, so we cannot have coefficients here. ठीक है, we cannot separate them by x here and y here. ठीक है, यहाँ पे कुछ और भी हो सकता है. It is not necessary कि यहाँ पे x square y हो, x square या xy हो. यहाँ पे x square x अंडर रूट y भी हो सकता है, ठीक है, x y स्क्वायर रूट. इट कुड बी एनीथिंग, इट कुड बी एनी नॉन लीनियर फंक्शन. यहां पे x स्क्वायर की जगह sin x में लिख देता हूं, ठीक है. इट मे इन्वॉल्व any function of the dependent variable. Then we cannot separate the variables x and y here, so we cannot write this non-linear system into a matrix form. We can write only the linear systems into matrix form. I hope you get it. Faik, if you have any further question, you can ask me. Any other guy? We cannot write non-linear system into matrix form because the variables, dependent variables, are not linear here. Okay, only a linear system of first order ODEs can be transformed into a matrix form. I hope you get it. If you have any question, you can ask me.
सर t का कोई भी फंक्शन हो सकता है इस केस में?
Yes, t could be any function. ठीक है, यहाँ पे t square है, आप यहाँ पे कुछ भी लिख सकते हैं. You can write any function means exponential of t, और यहाँ पे आप लिख सकते हैं sin t. ठीक है, t का कोई भी फंक्शन हो, it doesn't matter because it is independent variable. ठीक है, जैसे कि हमने यहाँ पे सिस्टम में लिखा, in the system we have written here a11 of t. a11 of t is a function of any function of t, but it should be defined continuous function. ठीक है, so this is your system of first order ODEs. What we are going to deal, first we shall deal homogeneous linear systems. Homogeneous system of linear equations, first order, the system of linear equations, plus first we will deal with this coefficient matrix A. Here the coefficient matrix A is basically, it is a function of t times x. Okay? Because this matrix, it has entries which are functions of t. But first we shall deal when this coefficient matrix is a constant matrix. It contains only the constant entries. What does it mean? That they are no more the functions of t. Okay, they are not the functions of t, they are constants. Constants, they could be any constant, real number, for example, 2, 3, 5, anything. So first we shall deal this linear system with constant coefficients plus homogeneous. We're not dealing first the non-homogeneous system. We are going to deal this system and how to solve it. We'll learn how to solve it. And this system can be written as how? d by dt of x is equal to a times x plus 0, nothing. This one, where a has the entries which are constants. So first we shall see how to handle these kind of systems, how to solve these kind of systems. Linear homogeneous system of first order ODEs with constant coefficients. Okay, with यहाँ पे non-homogeneous with constant coefficients. Okay, what is an example of this? Let's write an example of this system where I can write this one here. If I remove this, then this system is what? It is a first order homogeneous linear system with constant coefficients, because the matrix, it contains only the real numbers. So this is your, it is in fact basically dx by dt is equal to 2x1 minus plus 3x2, and dx2 by dt is equal to 9x1 minus 7x2. So these kind of systems we shall deal, we shall discuss, and we'll find the ways how to solve it. This is a 2 by 2 system. We can write a 3 by 3 system. For example, dx1 या आप इसको dx by dt is equal to 2x minus 3y minus z, and dy by dt is equal to negative x plus 7y minus 3z, and dz by dt, it could be only y minus z. Okay. This is a 3 by 3 system. It has 3 dependent variables, unknown variables, and 1 t is independent variable. So this system can be written as d by dt of x, y, z is equal to, in a matrix form, we write the coefficient of x, y, and z. It is 2 minus 3 minus 1, minus 1, 7, minus 3. Here, we don't have coefficient of x, so we can write 0. So 0, 1, and minus 1 times x, y, and z. So this is basically a 3 by 3 system which contains 3 first order ODEs. If you have any question, you can ask me. What is now the solution of this system of first order ODEs, which is homogeneous with constant coefficient, obviously. Okay. Now, what is the solution of this system? Obviously, the solution is a vector. The solution must be a vector x1 of t, x2 of t, okay, and there should be functions of t. Okay, here we must have function of t. Here we must have some function of t, so that if we put x1 here, x2 here, x1 here, x2 here, okay, if we put this solution, each solution x1 and x2 here in this system, the system turns into identity. Both sides become equal. Okay, left hand side of each differential equation must be equal to the right hand side of the respective first order differential equation. Okay, this is what we call the solution of the first order system. Same as we discussed the solutions of simple differential equations. Okay, let me clean this board maybe. Let's go back here. I'm gonna pause the video for 1 minute. Verification of solutions. Now, what is a solution and how to verify it. Let's do an example of this thing and we'll move forward. For example, if we have a linear system of this form, dx1 by dt is equal to x1 plus 3x2, and then dx2 by dt is equal to 5x1 plus 3x2 again. And we have to verify that. Still, we don't know how to find this solution. Okay, we are okay. Board nahi hai, theek hai. Let me change the board. Sorry, this one. So this is an example: dx1 by dt, dx2 by dt is equal to x1 plus 3x2 and 5x1 3x2, and we need to verify that x1 x2, which is a x vector, and this is equal to what? It is 1 minus 1 e raised power 2t, or we can multiply this thing inside and we get e raised power 2t and negative e raised power 2t. Okay, so this is negative e raised power minus 2t here. Minus, minus, minus. Power में minus. We need to verify that whether this is a solution of the given system or not. So this system can be written into a matrix form d by dt of what? x1, x2 is equal to, into matrix form 1, 3, 5, 3 times x1, x2. We need to verify, or you can write this thing with the derivative inside dx1 by dt and dx2 by dt. Okay. Now, if this is your solution, if you need to verify that this is your solution, what you have to do, you have to take its derivative. So its derivative would be dx bar by dt. What does it mean? It is dx1 by dt over dx, and dx2 by dt. We need to take the derivative separately of each solution. So its derivative is what? E raised power minus 2 ka derivative. It is minus e raised power minus 2t and minus 2 as well. और यहाँ पे minus minus plus हो जाएगा 2 e raised power minus 2t. So this is the derivative of the solutions x1 and x2. This is your left hand side. Okay. Now let's try the right hand side. On the right hand side, you have to see this. And what is this? It is your RHS, right hand side, 1, 3, 5, 3. And what are the values of x1? X1 is e raised power minus 2t, e raised power minus 2t, and the second one is negative e raised power minus 2t. So you have to multiply matrix with the vector. What do we get here? This into this plus this into this. So it becomes e raised power minus 2t minus 3 e raised power minus 2t, and 5 into this minus 3 into this. 5 e raised power minus 2t minus 3 e raised power minus 2t, and it becomes what? E raised power minus 2t minus 3 e raised power minus 2t. It is minus 2 e raised power minus 2t, and this one is 2 e raised power minus 2t. So this is your right hand side. Okay, this is your right hand side. You can see that this right hand side is equal to the left hand side. So this is what this is the solution of this system. Both equations should be satisfied. Okay. So the solution of the system is actually a vector, and we can obviously write this solution into this form. A vector, constant vector, a vector which contains constant entries into some function of t. Okay. So this is how we can verify that whether a given vector is a solution of first order system or not. Now we can see that solution is always of if we have a single first order linear ODE, okay, d, for example, dy by dt is equal to some 3 times y. Okay. This is a single first order ODE which is linear and homogeneous. Okay. Then what would be the solution of this? अगर हम इसको solve करें by using some technique of linear ODE. Sorry, board. I need to change the board. Yes. If we have this kind of differential equation, which is a single first order linear homogeneous differential equation, then we can solve this thing using separation of variables or using the technique which we use to solve linear first order ODEs. And it is homogeneous as well. By using separation of variables, we can write 1 over y dy is equal to 3 dt. Okay, then its integral, both sides is natural log of y is equal to 3t plus c. Then y could be what? It is e raised power 3t plus c. And finally, we can write y of t is equal to some constant times e raised power 3t. Okay. So the solution of linear differential equation, which is homogeneous with constant coefficient, is always of this form. ठीक है? अगर single equation है तो ये है. अगर system of two equations हैं तो solution किस type का होगा? अभी हमने जो we just have seen an example. In that example, we saw that the solution is what? It is 1 minus 1 times e raised power 2t. Okay. So this is what? This you can write it kind of one single entry, a constant times e raised power some lambda t. अगर system है आपके पास system of two differential equations which are first order, homogeneous, linear with constant coefficients, then the solution must be of this form. अगर आपके पास system of n equations है, system या आप कह सकते हैं n by n system है आपके पास differential equations which contain n differential equations in n unknown variables, then the solution will be of this form. Some constant, you can say the c1, c2, so on, cn, constant vector times some exponential function of t. So in general, देखिए अगर आपके पास सिंगल इक्वेशन है तो एक कांस्टेंट आया टाइम्स एक्सपोनेंशियल ऑफ सम कांस्टेंट टाइम t. दो इक्वेशंस हैं तो ये भी आपके पास एक वेक्टर है कांस्टेंट फैक्टर टाइम्स एक्सपोनेंशियल ऑफ सम कांस्टेंट टाइम्स t. अगर आपके पास n by n सिस्टम होगा तो आपका सॉल्यूशन इस टाइप का होगा और a constant vector times some exponential function of, here you can have constant times t. So in general, the solution, we can generalize that the solution of a system of first order homogeneous differential equations is of this form. Okay. I hope you get it. If you have any question, you can ask me. Till here, if you have any question, you can ask me. The next thing is superposition principle. We used to discuss it for simple differential equations as well. Now we are going to discuss the superposition principle as well. But remember that in general, we can assume that the solution is basically of this form. बल्कि पहले let us discuss this thing and then we'll discuss the superposition principle. Now, if we assume that the solution is of this form, if we assume that the solution of an n by n system of n differential equation first order is of this form, and the system is what? D by dt of power x, sorry, x bar is equal to a times x bar. Okay, this is your homogeneous linear system. If this is the solution, and we can further write that this is, आप इसको c ना कहें, some other कह दें, c constant of integration से confuse करेगा, so it is k1 k2 कह दें, so on kn कह दें, ठीक है, और in general इसको आप k vector कह दें and times e raised power lambda t, ठीक है. So this is x vector, which is equal to what? K vector, where k vector is what? It is this vector times e raised power lambda t. If we assume that this homogeneous linear system with constant coefficient, it has this kind of solution. If it is a solution, then it must satisfy that system. So if we put it here, then what do we obtain? D by dt of x bar की value of solution की put कर दें, k e raised power lambda t is equal to a times solution x क्या है? It is k times e raised power lambda t. ठीक है, यहां पे डेरिवेटिव, ये तो कांस्टेंट वेक्टर है, इस पे डेरिवेटिव अप्लाई नहीं होगा, इट विल गो आउटसाइड. k वेक्टर इन डेरिवेटिव ऑफ दिस थिंग इज व्हाट? इट इज lambda e raised power lambda t and is equal to a into k. ठीक है, a into k e raised power lambda t. Now, this k vector and this is a k vector. ठीक है, आप that is identical. ठीक है, e raised power lambda t, e raised power lambda t. ठीक है, this is also identical. ठीक है, if we assume that k vector is not a zero vector, if k vector is not a zero vector, and also e raised power lambda t, exponential function is never zero. ठीक है, if this k vector is homogeneous zero vector, then the solution will become a trivial solution, and every linear system must have a trivial solution. x अगर zero put करें तो दोनों sides satisfy हो जाती हैं, we get the trivial solution. Trivial solution क्या होगा? Trivial solution is x bar which contains 0 0 so on 0. This is your trivial solution of the system. But we are not interested in trivial solution. We need to find non-trivial solution. So we assume that k bar is non-zero. An exponential function is always non-zero. So we can eliminate this k and exponential factor from here. And we can write lambda is equal to a times बल्कि आप नो, आप इसको उधर ले जाएं पहले. So what would it become? This k times lambda minus a times k times e raised power lambda t is equal to, आप इसको zero vector कह दें. ठीक है, now this is always non-zero. ठीक है, यहां पे हमने कहा. Then अगर आप इसको eliminate करें तो from here we can obtain k times lambda, बल्कि आप k को उधर लिख लें, k times lambda I minus a times k is equal to 0 vector this. ठीक है, अच्छा, what you obtain this equation. ठीक है, now we can always assume that the solution of the first order system is of this form, where what we have to find this k vector which is unknown and this lambda which is unknown. ठीक है. So we assume that this is non-zero vector and this is always non-zero. By solving this equation, we obtain this thing. And as this is non-zero, we can eliminate this thing and we can write this equation. Okay. Where k is unknown and we have to determine, and lambda is also unknown, we have to determine. We know that the solution is of this form. If we can find this vector, these unknown values k1, k2, so on, kn, plus this unknown value lambda, okay, then by using that linear system, given linear system, then this will be the solution of the given linear system. So by inserting this solution into the differential equation system of differential equation, we arrive at this equation. Okay. Now, what is this? This is an equation which has lambda into I minus a. हमने यहाँ पे I क्यों लिखा? When we took k common from this equation, why did we write here I? Can anyone tell me? Anyone? Two people are waiting to join. Can you tell me? जी?
जब हम k कॉमन ले लेंगे तो a क्योंकि एक मैट्रिक्स है और उसके अंदर से हम कुछ सबट्रैक्ट करें तो उसको भी एक मैट्रिक्स ही होना चाहिए, तो इसलिए वो lambda I हो जाएगा.
Definitely, because you can see that here a times k is a vector, k times lambda is a vector. When you took this common k, here lambda is only a constant. Okay, अगर यहाँ पे k को common लेंगे, ये लिखेंगे lambda minus a, then mathematically this expression is wrong, because we cannot subtract a matrix from a single entry which is constant. Okay, so we have to put here an identity matrix of same order. The order of a and I must be same order. A का order यहाँ पे क्या है? क्योंकि ये n by n system है, तो आपका A का order n by n है, तो I का order भी क्या होना चाहिए? n by n. Both these should be square matrix, and I is identity matrix. I hope you know what is identity matrix. Okay. So now we obtain this equation. This equation help us to find the unknown vector k and lambda, which is here in the exponential power. We start with the with the same equation, lambda I minus a times k vector is equal to 0 vector. यहाँ पे 0 vector आएगा, not only 0, because the left hand side is a vector, so my right hand side must be a vector as well. Now this equation, ये क्या है? What is this equation? Can anyone tell me? So Fatima, what is this equation?
Characteristic equation?
No. It is a linear system. It is a homogeneous linear system. Homogeneous linear system है या नहीं? कैसे है? K एक वेक्टर है और ये क्या है? एक मैट्रिक्स है. ठीक है, अगर इस मैट्रिक्स को हम कह दें कि ये वाला मैट्रिक्स जो है ये B है, ठीक है, ये B एक मैट्रिक्स है क्योंकि लैम्डा इंटू I और A मैट्रिक्स, ठीक है, ये एक मैट्रिक्स है. लैम्डा I माइनस A, ये भी एक अगेन एक मैट्रिक्स होगा, टाइम्स अ वेक्टर इज इक्वल टू 0 वेक्टर. व्हाट इज दिस? दिस इज होमोजेनस लीनियर सिस्टम. ठीक है, अच्छा, लीनियर अलजेब्रा में यू मस्ट हैव स्टडीड होमोजेनस लीनियर सिस्टम जो होते हैं, इसका ट्रिवियल सॉल्यूशन ऑब्वियसली एग्जिस्ट करता है. ये वेक्टर को अगर आप 0 वेक्टर ले लें तो उसका सॉल्यूशन होगा. नॉन ट्रिवियल सॉल्यूशन किसी भी होमोजेनियस लीनियर सिस्टम के कब एग्जिस्ट करते हैं? एनीवन?
हमसे जब उसका डिटर्मिनेंट 0 होता है।
यस, जब उसका डिटर्मिनेंट, किस चीज का डिटर्मिनेंट 0 होता है?
हमसे इस केस में अगर बी का डिटर्मिनेंट 0 होगा तो
कोएफिशिएंट मैट्रिक्स का. If you have a homogeneous linear system, then it must have non-trivial solutions only if this B is a singular matrix. Singular matrix means इसका determinant जो है वो 0 होगा. ठीक है? B का determinant 0 होने से मुराद क्या है कि आपका this is a homogeneous linear system. ठीक है? It must have non-trivial solutions for or in order to obtain non-trivial solutions, to obtain non-trivial solutions, what we have to write here, or what we should have, determinant of B or determinant of lambda I minus A must be 0. If this is true, then we can find the non-trivial solutions of this homogeneous linear system. And non-trivial solutions of this homogeneous linear systems are what? They are k vectors. Okay? That would be a k vector. आपके पास ये homogeneous linear system है, यहां से अगर आपके पास determinant of B 0 है, तो you can find non-trivial solutions of this non-trivial solutions K. ठीक है? You can find non-trivial solutions of K from this system or from this system. ठीक है? Provided that the coefficient matrix is singular, means its determinant is 0. अच्छा, अब आपने क्या assume किया था कि solution जो है वो इस फॉर्म का है. ठीक है? Solution इस फॉर्म का है, which contains an unknown vector k and an unknown value of lambda. ठीक है? यहां से आपके पास दो इक्वेशंस हैं. ठीक है? एक ये आपके पास होमोजेनियस लीनियर सिस्टम है, यहां से आप क्या फाइंड कर सकते हैं? k वेक्टर. और ये जो इक्वेशन है इसमें k तो नहीं है, इसमें क्या है? लैम्डा है, i है, a है. ये आपके पास डिटर्मिनेंट ऑफ दिस मैट्रिक्स है. ठीक है? एंड दिस इज इक्वल टू 0. यहां से आप क्या फाइंड कर सकते हैं? लैम्डा, बिकॉज ओनली अननोन हियर इज लैम्डा. A is known matrix which we can obtain from the given linear system. I is identity matrix, we know it. Only lambda is unknown. From this equation, and this is called characteristic equation. Okay? Linear algebra में आपने पढ़ा होगा. ये equation क्या है basically? It is a polynomial equation. Polynomial equation of degree क्या होगी इसकी? n. क्यों? क्योंकि a का ऑर्डर n है. आपके पास एक n by n मैट्रिक्स है. ठीक है? उसका डिटर्मिनेंट अगर आप 0 पुट करें, ठीक है, तो आपके पास ये मैट्रिक्स जो है इसमें लैम्डा डायगोनल्स में होगा. ठीक है? और कितने लैम्डास होंगे? n लैम्डास होंगे. तो आपके पास यहां पे पॉलिनोमियल बनेगा डिग्री n का. ठीक है? डिग्री n का पॉलिनोमियल बनेगा. उस पॉलिनोमियल की कितनी मैक्सिमम रूट्स हो सकती हैं? n रूट्स हो सकती हैं. तो आपके पास लैम्डा की n वैल्यूज आ सकती हैं. ठीक है? तो फिर हर लैम्डा की वैल्यू के लिए हम एक ये वेक्टर जो है अननोन वेक्टर फाइंड कर सकते हैं, which would be the solution of this homogeneous linear system. And ultimately for n lambdas we can find n values of these vectors. ठीक है? तो आपके पास इस टाइप के n solutions होंगे गिवन लीनियर सिस्टम की n सॉल्यूशंस होंगे. let us do an example of this thing. बल्कि हाँ, वो ऊपर वाली जो एग्जांपल हमने की थी ये वाली.
इसके अंदर हमने आइगन वैल्यू और फिर आइगन वेक्टर्स ढूंढना, मतलब
जी
आइगन वैल्यूज और आइगन वेक्टर्स हमने खोल रहे हैं ना.
हाँ जी, अभी हम उनकी भी बात करते हैं. आइगन वैल्यूज एंड आइगन वेक्टर्स. Let me talk about the eigenvalues and eigenvectors as well. By solving this characteristic equation, where is that equation? This one. By solving this characteristic equation, we obtain n values, lambda 1, lambda 2, so on, lambda n. Because we obtain, by solving this characteristic equation, we obtain a polynomial of degree n, which can have at most n values. These values are called eigenvalues. Eigenvalues. And corresponding to each eigenvalue, we can find a vector here. From by putting lambda 1 here, we'll have a known matrix, coefficient matrix, plus an unknown vector k. Okay. By solving this homogeneous linear system, we can obtain k1 corresponding to lambda 1. Corresponding to lambda 1, we can find k1 vector. Corresponding to lambda 2, we can find k2 vector, and so on. And corresponding to lambda n, we can find kn vector. Okay, by putting term by term here, lambda 1, solve it, lambda 2, solve it, lambda 3, solve it, and so on, you will get respectively k1, k2, so on, kn. And these vectors are called eigenvectors. Let me have the chalk. These vectors are called eigenvectors. अब आपके पास अगर आपके पास n eigen values हैं और corresponding n eigen vectors हैं, then we can write how much solutions. Then we can write n solutions. हमारे पास solution क्या था? Corresponding to each eigenvalue and eigenvector. We can write n solutions of given linear system. हम कहेंगे जी x1 पहला सॉल्यूशन है जिसका आइगन वेक्टर फर्स्ट एक्सपोनेंशियल ऑफ लैम्डा 1 t. ठीक है, ये उसका पहला सॉल्यूशन है. हमने क्या अस्यूम किया था शुरू में कि सॉल्यूशन किस टाइप का है? इस टाइप. ये है ना, हमने ये अस्यूम किया था कि सॉल्यूशन जो है वो इस टाइप का है. ठीक है, एंड दिस सॉल्यूशन कैन बी रिटन एज, अगर k1 k2 सो ऑन kn वेक्टर को अगर हम k वेक्टर कह देते हैं तो e रेज़ पावर लैम्डा t. तो सॉल्यूशन इज ऑफ दिस फॉर्म. ठीक है, अब हमारे पास कितने वेक्टर्स हैं? n वेक्टर्स हैं और कितनी ये वैल्यूज हैं लैम्डा की? n वैल्यूज हैं. तो आपके पास कितने सॉल्यूशंस होंगे? n सॉल्यूशंस होंगे. और सारे के सारे सॉल्यूशंस इस फॉर्म में हम लिख सकते हैं. तो वी राइट हियर x1 इज ऑफ दिस फॉर्म. ठीक है, x2 हमने कह दिया इज अनदर सॉल्यूशन व्हिच इज k2 वेक्टर e रेज़ पावर lambda 2t and so on xn vector. Xn vector is a solution which is kn vector times e raised power lambda n of t. So we obtain n solutions. We can check whether these solutions are linearly independent or not. We can check whether these solutions are linearly independent or not. If they are linearly independent, we can write the general solution. How we can write the general solution? We can use the principle of superposition.
सर
जी 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 फातिमा।
सर हमने जब एलए में पढ़ा था कि जब रिपीटेड भी तो हो सकती है हमारी लेमडा की वैल्यूज और उसके करस्पॉन्डिंग ये हो सकता है कि एक लेमडा की वैल्यू के लिए मल्टीपल हमारे वेक्टर्स हो.
We'll discuss that thing in the next class when these eigenvalues are repeated or distinct. We are discussing here an ideal case when all the lambdas are distinct. Okay? When all the lambdas are real and distinct, then all these solutions will be linearly independent. And how we can check whether they are linearly independent or not will be using Wronskian. ठीक है, एक तो ट्रेडिशनल कंडीशन है लीनियर इंडिपेंडेंट चेक करने की, जो कि आप एक्सप्रेशन लिखते हैं. क्या एक्सप्रेशन होता है वो? लेट मी राइट दैट थिंग अगेन फॉर यू पीपल. लीनियर इंडिपेंडेंट कैसे चेक करते हैं? लीनियर इंडिपेंडेंस और डिपेंडेंस ऑफ सॉल्यूशंस. एक तो ट्रेडिशनल तरीका है, यू राइट C1 x1 वेक्टर प्लस C2 x2 वेक्टर प्लस सो ऑन प्लस Cn xn सॉरी x नहीं k वेक्टर, आप x कह सकते हैं, आप इज इक्वल टू 0 वेक्टर. ठीक है, अब यहां से आपके पास x1 x2 सो ऑन क्या है? x1 C1 x1 जो है वो k1, ठीक है, e raised power lambda 1 t प्लस C2, या इन जनरल आप इसको डिस्कस कर लें. If all these constants C1 C2 Cn, if all these constants after solving this system, because this is a system of equations, क्योंकि k1 जो है वो वेक्टर है, इसका कोएफिशिएंट एक्सपोनेंशियल ऑफ lambda 1t है. अगर आप इसको इस तरह हैंडल करें, C1 k1 e raised power lambda 1t plus C2 k2 e raised power lambda 2t plus so on plus Cn e raised kn e raised power lambda nt equal to 0 वेक्टर. अगर आप इसको सॉल्व करना चाहें इस तरह, तो इट वुड बी वेरी डिफिकल्ट, बिकॉज यहाँ पे n इक्वेशंस हैं. जब k1 की वैल्यू पुट करेंगे, ये वेक्टर है, ठीक है, साथ ही मल्टीप्लाई होगा, k2 का डिफरेंट वेक्टर है, साथ ही डिफरेंट मल्टीप्लाई होगा. इस सिस्टम को सॉल्व करना बहुत मुश्किल है. ठीक है, what we have to do here, we have to find some easy method to check whether these solutions x1 x2 so on xn, they are linearly independent or not. For that we find Wronskian, and Wronskian in this case would be what? It is, you can denote it by W. Okay. W is what? It is the determinant of, आपके पास जो k वेक्टर है, k वेक्टर क्या होगा, या आप x वेक्टर को कह दें, यहाँ पे इन जनरल k1 होगा. k1 की एंट्रीज आप यहाँ पे लिख दें. ठीक है, यहाँ पे मैंने इसमें लिखा हुआ है, लेट मी, या इन जनरल आप x1 की एंट्रीज लिख दें. x1 की एंट्रीज अगर आपके पास x11 x21 so on xn1, ठीक है, पहला वेक्टर लिख दिया आपने, पहला सॉल्यूशन वेक्टर x1. ठीक है, अगर x1 आपके पास सॉल्यूशन वेक्टर है तो डेफिनेटली उसमें n एंट्रीज होंगी, ठीक है। तो पहले वेक्टर को आपने यहाँ पे लिख दिया, दूसरे वेक्टर को कॉलम वेक्टर है ना, तो कॉलम वेक्टर्स में लिखेंगे। यहाँ पे 1 2 x 2 2 सो ऑन x, यहाँ पे 2 n नहीं n2 आ गई, ठीक है, एंड सो ऑन एंड सो ऑन एंड सो ऑन। यहाँ पे x 1 n x 2 n एंड सो ऑन x n n। ये आपका Wronskian है, ठीक है। डिटर्मिनेंट ऑफ ऑल द सॉल्यूशंस इन द कॉलम वेक्टर्स, ठीक है। आपने इन सॉल्यूशंस को यहाँ पे कॉलम वेक्टर्स में लिख दिया, ठीक है। अगर ये डिटर्मिनेंट, if this determinant is non-zero for all values of t belongs to I, ठीक है, for all values of t belongs to I, ठीक है, because they are functions of t, because they involve exponential of lambda 1 t as well. If this Wronskian is non-zero for all values of t, then we say that x1, x2, so on xn, they are linearly independent. If they are linearly independent, then we can write the general solution by using this principle of superposition. How can we write the solution? By using the principle of superposition, we can write the general solution of the linear system, general solution of the linear system of equations is x bar of t is equal to some constant of integration times x1 of t plus some other constant x2 of t plus so on plus cn xn of t, where x1, x2, so on xn are linearly independent solutions, and c1, c2, so on cn are constants of integration, are parameters of the solutions. Okay. This is what the principle of superposition is as well. If we have two different linearly independent solutions of one differential equation, then their linear combination is also a solution of the given system. ये हमने कई दफा पढ़ा है, principle of superposition. You can read it in my notes. I shall upload it. Then in case of any problem, you can discuss these things with me. Okay. And fundamental set of solutions क्या होता है? I told you, अगर ये सारे linearly independent solutions हैं, तो इनका जो set होगा, that would be a fundamental set of solutions. And if we have a fundamental set of solutions for any system of differential equation, we can write the general solutions. If you have any question, you can ask me. Otherwise, we are going to stop till here today. In the next lecture, we shall discuss how to find eigenvalues and eigenvectors of any particular given linear system. If you have any question, you can ask me. Otherwise, I'm going to terminate this meeting.
एक क्वेश्चन था,
जी बोलें।
जब हम रॉन्स्किन ने पहले पढ़ा था तो उसके अंदर हम डेरिवेटिव्स निकाल रहे थे
जी, it's basically these are two different forms of Wronskian. In that case, आपके पास functions थे, they were basically real valued functions, n functions थे, ठीक है। यहाँ पे आपके पास vectors हैं, n vectors हैं, they already form the matrix, ठीक है। And this is a different situation here. Now the solutions are basically vector functions, ठीक है। वहां पे आपके पास क्या था? Real valued functions थे, ठीक है। And we can I'll show you the proof of these two things if you want. In the next lecture, or you can separately have a meeting, Zoom meeting with me. I'll show you the more detail of these two situations of how to derive the Wronskian. Okay.
Yes.